Hi children, today we are going to see example 1.2 and example number 1.3. Okay children, so what's the question for example 1.2? See, read it. If a body gives out 10 to the power of 9 electrons, okay, right? So the body is giving out how many electrons? 10 to the power of 9 electrons every second. How much time is required to get a total charge of 1 coulomb from it? Okay, so a body is emitting or a body is giving out 10 to the power of 9 electrons every second. In that case, in order to get 1 coulomb of charge from that body, how much time is required? Okay, so first of all, we are going to calculate the total charge given by the body in 1 second. Okay, right? They have given you the number of electrons, but they have not given you how much amount of charge is being given out, right? So using the formula Q is equal to NE, we are going to calculate the total charge given out in 1 second. So from that we will be calculating the time required to get 1 coulomb of charge. Okay, so now what are the given data they have given you? First of all, we have to write down the given data, then the formula, then the substitution. Okay, right? Formula has mark, right? You have to substitute it in the formula. For that also you have mark. Okay, so don't forget to write the formula. This is a common mistake which the children will do. Okay, right? That they know the formula, so they will just substitute it directly and go. Don't do like that, children. You have to write the formula and then only you have to substitute the values. Okay, right? So everything has got mark in your public examination. Okay, so come on, let's list down the given data. Okay, right? So what is given? If a body gives out 10 to the power of 9 electrons every second. Okay, so the number of electrons given out every second, that is, let us represent it as n, is equal to how much? 10 to the power of 9 electrons. Okay, right? How much time is required? Right? So they have asked you to calculate the time required. Okay, time required for what? To get a total charge of 1 coulomb, right? So the charge is equal to 1 coulomb. So let's start to solve the problem. Okay, right? So what did I tell you? They have given you the number of electrons. We have to calculate the charge given out. Okay, so we know the formula for charge. Do you remember, children? Charge given out in 1 second will be charge one second, okay, will be equal to how much, children? N into E. I am not representing that to be equal to Q because already I have written the given amount of charge to be Q, right? So that's why I am not writing as Q is equal to NE. Okay, right? Instead of that, I am writing it as charge given out in 1 second is N into E. Okay, so what's the value for N? They have given you, substitute it. So 10 to the power of 9, and the value of E we know it to be equal to 1.6 into 10 to the power of minus 19 coulomb. So E value will be equal to 1.6 into 10 to the power of minus 19. Okay, so what this becomes? 1.6, 10 to the power of plus 9 and 10 to the power of minus 19 will become equal to 10 to the power of minus 10. Okay, right? So this much amount of coulomb. Okay, so the charge given out in 1 second will be equal to this much amount of coulomb. Okay, 1.6 into 10 to the power of minus 10 coulomb. Okay, now time required to get the charge of 1.6 into 10 to the power of minus 10 coulomb. Okay, right? So what is the time required for getting this charge, children? That is equal to 1 second, right? Every second, am I right? So this is equal to 1 second. Okay, therefore time required to get a charge of 1 coulomb, okay, will be equal to how much? 1 second divided by 1 second divided by 1.6 into 10 to the power of minus 10. Okay, so what is this going to be equal to? 1 divided by 1.6 into 10 to the power of minus 10. 1 by 1.6 will be equal to 6.25. Okay, 6.25 into 10 to the power of 9. Okay, right, this minus 10, when it goes up it will become plus 10, and when we change the decimal point it becomes equal to 10 to the power of 9. Okay, right. So therefore time required to get a charge of 1 coulomb will be equal to this much seconds. Okay, and in your book they have calculated it for years. Okay, right. So let us convert it into years. Okay, right. So how will you convert it into years? 6.25 into 10 to the power of 9 second divided by, okay, right. So year, am I right? So in a year how many days are there? 365 days. In that 365 days each day has 24 hours. In that 24 hours you have 60 minutes and 60 seconds. Okay, right. Calculate all these values, children. When you calculate it, it works out to be equal to 198.18 years. Okay, so therefore what have we found? We have found that time required to get a charge of 1 coulomb is equal to this many years, right? So this can be approximated to be equal to around 200 years. Okay, in my previous video I have told you, in quantization of charges I have told you, children, that 1 coulomb is a large unit of charge. We always go for microsecond, millisecond, not second, I am sorry, we will always go for 1 microcoulomb, 1 millicoulomb, 1 nanocoulomb. Okay, right. So see, in order to get a charge of 1 coulomb, how much time is required? 200 years is required. Okay, right. So this itself proves that 1 coulomb is a very large amount of charge. Okay, children, right. You don't have to go for this approximation, you can leave it with this itself, right. Okay, no problem. Okay, so this is how we have to solve this problem. This is a very simple problem. Okay, children, right. So the next problem is example 1.3. Example 1.3 is also a very simple problem only. So what is the question? Read the question. Example 1.3, how much positive and negative charge is there in a cup of water? Okay, right. So in a cup of water, how much amount of positive and negative charges are there? Okay, right. So cup of water means, you know, that it is nothing but hydrogen molecule. Okay, right. So hydrogen molecule means what? H2O. Okay, right. So in this H2O, how many hydrogen molecules are there? 2 hydrogen molecules. So the number of protons in hydrogen will be 2 and number of protons in oxygen will be 8. Okay, right. So the total number of protons will be protons or electrons. You know that number of protons and number of electrons will be always the same, right? So the total number of protons or electrons will be equal to 10. Okay, children, let's have this and go for solving. Okay, right. So here you don't have any given data and all, you have to start solving it, right? So now we are going to assume. Okay, right. So we are going to assume, what are we going to assume? That in a cup of water, how much amount of water is there? 250 grams of water is there. Okay, right. So let us assume, so this is, let it be like this. So assume that in a cup of water 250 gram is there. Okay, right. And we also know molecular mass of H2O is 18. Okay, right. So molecular mass of hydrogen or water is 18 gram, right? That also we know. Okay, right. We also know that number of molecules present in 18 gram of water. Okay, right. So number of molecules present in 18 gram of water. What is this, children? This is nothing but your Avogadro number. Okay, right. Avogadro number is equal to how much? Avogadro number we know So what's the value? 6.02 into 10 to the power of 23 molecules. Okay, right? So if in 18 gram of water this much molecules are present, means therefore number of molecules present in a cup, that is how much grams? 250 gram. Okay, right, of water equal to how much, children? 6 point, this Avogadro number, 6.02 into 10 to the power of 23 into 250 divided by this 18. Okay, this 18. Okay, right, and you calculate this, this works out to be equal to 8.36 into 10 to the power of 24. Okay, so totally how many number of molecules are there in 250 grams of water? This much number of molecules are there in 250 grams of water. Okay, children, right? So now we know this much number of molecules are there. Now we have to calculate how many electrons or protons are present in cup of water, right? Therefore total number of electrons or protons in 250 gram of water will be equal to what? N dash, right? Let's represent it as N dash. Okay, right? This N dash will be equal to N into E. Okay, right? Sorry, N into 10. Okay, N into 10, because the total number of protons or electrons is 10 here. Am I right? We have already calculated how many electrons or how many protons are there in a molecule, right? 10 protons or 10 electrons, right? So this is going to be equal to N into 10. Okay, children, and what's the value of N? We have calculated 8.36 into 10 to the power of 24 into 10. Okay, so this works out to be equal to 8.36 into 10 to the power of 25. Okay, this is equal to this much, right? So the total number of electrons or protons present in water molecule will be equal to 8.36 into 10 to the power of 25. Okay, right? So from this we have to calculate the total charge carried by the electrons or protons present in a cup of water. Okay, so therefore total charge present in a 250 gram of water, right? 250 gram means, I mean a cup, right? Okay, 250 gram means a cup of water, right? So that is Q will be equal to what? N into E. Here it is here N dash into E. Okay, right? So what is the value of N dash? We have calculated 8.36 into 10 to the power of 25 into 1.6 into 10 to the power of minus 19. Okay, and when you calculate this, this works out to be equal to how much, children? 1.33 into 10 to the power of 7 coulomb. Okay, right? So if they have just asked for how much positive and negative charge is there in a cup of water, right? How much charge? 1.33 into 10 to the power of 7 coulomb of charge is present in a cup of water. Assuming that in a cup of water, how many grams of water is there? 250 gram of water is there. Okay, this assumption we have to remember, children. If we remember this, this can be done easily. Okay, right? These things and all we already know from chemistry. So the same thing we have done here. So from that we have calculated the total number of electrons present in 250 gram, and from that we have calculated the total charge present in 250 gram, that is in a cup of water. Okay, children, right? Hope you have understood both the questions, children. Go through it. If you have got any doubt, you can ask me in the comment section. I'll explain to you in my next video. Thank you, children.